oligopoly is a market structure in which a small number of firms are operating in a market with substantial barriers to entry. Because relatively few firms compete in such a market, each firm can significantly influence the market price and hence affect rival firms. Consider the flight between Hong Kong and Osaka. There are only several airlines operating such a direct flight. Due to heavy upfront investment and regulations, it is not easy for new airlines to enter this market. Because of these, we can consider this market as an oligopoly market. One of the key features of an oligopoly market is that, when the owner of a firm needs to make a business decision, she will take into consideration the business strategies of other firms. For example, if Airline A offers a discount for its flight, Airline B will probably suffer from losing some of its customers. Thus, each airline will base her own business strategy on her beliefs about the strategies of the competitors. In other words, there is strategic interaction between firms. In economics, one classic model to analyze this oligopolistic competition is the Cournot Competition. Cournot Competition was outlined by a French philosopher, mathematician, and economist, Antoine-Augustin Cournot, in 1838. In a Cournot model, firms compete on the amount of output they produce and let the market to determine the price. One crucial feature in the Cournot model is that firms decide on their output levels simultaneously without knowing the output level of their competitors. Let's take a look at the simple Cournot model. Imagine that there are only two firms in the market, and they are producing identical products. The market output is made up of the outputs of these two firms. Mathematically, it can be expressed as capital Q equals QA plus QB, where capital Q is the market quantity of output, and QA and QB represent the individual firms' outputs respectively. Suppose the inverse market demand is estimated to be P equals 24 minus Q. Substituting the individual firm's quantity, we have P equals 24 minus QA plus QB. From the equation, we can see that the outputs by firm A and B have the same impact on price. Each additional unit of output produced, either by firm A or firm B, will lower the market price by $1. Now, let's consider firm A. First, what is the demand that firm A faces? Recall the inverse market demand is given by P equals 24 minus QA plus QB. By rearranging the terms, we can find the demand faced by firm A as P equals 24 minus QB minus QA. The term 24 minus QB can be regarded as the intercept, while the slope of the equation is given by the coefficient of QA, which is -1 here. We'll call this the residual demand faced by firm A. Next, what will the owner of firm A do in order to maximize the profit? The answer is straightforward. She'll look at its marginal revenue and marginal cost. So what is the marginal revenue of firm A? The total revenue TR of firm A is TRA equals P times QA. By substituting the expression of the residual demand, we have TRA equals 24 minus QB minus QA and multiplied by QA. And thus, TRA equals 24 times QA minus QB times QA minus QA squared. We can find out the marginal revenue by differentiating TRA with respect to QA. MRA equals DTRA over DQA. And thus we have MRA equals 24 minus QB minus 2 times QA. By comparing the demand and marginal revenue functions, we can see that 1. They share the common y-intercept. 2. The slope of MR is twice that of the inverse demand. The results are like the case in monopoly. Now, let's look at firm A's production cost. For simplicity, let's assume firm A has the following total cost function. TCA equals 12 plus QA squared, where 12 represents the fixed cost, which is the part of the cost that doesn't change with the output level. And the part of the cost function that changes with the output level is QA squared, which is the variable cost. The marginal cost can be found by differentiating the total cost function with respect to QA. MCA equals DTC over DQA. And thus, MCA equals 2 times QA. By equating marginal revenue and marginal cost, firm A's profit will be maximized. 24 minus QB minus 2 times QA equals 2 times QA. Thus, QA star equals 6 minus 1/4 times QB. This equation tells us one important insight. The profit maximizing level of output of firm A will be affected by the output produced by its competitor, firm B. The more firm A believes its competitor is producing, the less it should produce in order to maximize its profit. We call this equation, which describes firm A's optimal behavior, the best response function. Graphically, we can sketch out the best response function like this. For instance, if firm A believes the competitor is going to produce 3 units of output, it can maximize its profit by producing QA equals 6 minus 1/4 times 3 equals 5.25 units of output. But if it believes the competitor will produce more, say 5 units, it will then need to reduce its output to QA equals 6 minus 1/4 times 5 equals 4.75 in order to maximize its profit. How about firm B? If we simply assume firm B has the same cost structure, we can see that the situation it faces is actually symmetric, and thus, following the same analysis, we will obtain the best response function of firm B as QB star equals 6 minus 1/4 times QA. So now we know the optimal behaviors of the two competing firms. What will be the market outcome? The market outcome of this Cournot competition is given by the Cournot equilibrium, also called the Cournot-Nash equilibrium. As always, an equilibrium refers to a stable point. In a Cournot competition, it exists when both firms have no incentive to produce a different quantity of output. Or simply speaking, the equilibrium is where both firms produce a particular level of output that yields the highest profit to them, given the output produced by the competitor. We can understand more by looking at the best response functions. Suppose initially firm B produces nothing, that is, QB equals 0. How much should firm A produce to maximize profit? The answer is given by the best response function. QA star equals 6 minus 1/4 times 0 equals 6. This outcome is given by point x, 6, 0. Is it optimal for firm B? By looking at the best response function of B, we can see QB star equals 6 minus 1/4 times 6 equals 4.5. That is, given firm A produces QA equals 6, producing nothing is not profit maximizing for firm B. It should produce QB star equals 4.5. The outcome is given by point y, 6, 4.5. Now, given QB equals 4.5, what is the profit maximizing output for firm A? Again, we can check the best response. QA star equals 6 minus 1/4 times 4.5 equals 4.875. And so the market outcome changes to point Z, where QA equals 4.875 and QB equals 4.5. The market outcome will continue to evolve until we reach the intersection of the two best response functions, QA equals 4.8 and QB equals 4.8. When QA equals 4.8, the optimal output for firm B is QB star equals 6 minus 1/4 times 4.8 equals 4.8. Similarly, when QB equals 4.8, the optimal output for firm A is QA star equals 6 minus 1/4 times 4.8 equals 4.8. In other words, both firms will produce 4.8 units of output and have no incentive to deviate from this point. It is what we call the Cournot equilibrium. As QA equals QB equals 4.8, the total market output is Q equals QA plus QB equals 9.6. Substituting Q equals 9.6 to the inverse demand, we have P equals 24 minus 9.6, P equals 14.4. Thus, the revenue, cost, and profit of firm A are TRA equals P times QA equals 14.4 times 4.8 equals $69.12. TCA equals 12 plus QA squared equals 12 plus 4.8 squared equals $35.04. Profit A equals 69.12 minus 35.04 equals 34.08. And by symmetry, firm B's revenue, cost, and profit are the same. This is the simple Cournot model of duopoly. The key insight is that a firm's optimal level of output is affected by its belief on competitors' output. In particular, by looking at the best response function, we can see that one firm will reduce its output if it believes that the competitor is more aggressive, that is, producing more. Economists call this strategic substitutes.